Okay, in this lesson we're going to look at confidence intervals. Before we do, just a quick recap on a few things we've looked at before. Parameters are numbers that summarize data for an entire population. Really, parameters are characteristics of the population. Statistics are characteristics of the sample, of a sample. And we've spoken before about why we would sample and maybe some sampling methods. Generally we sample to save time and money. If the population contains millions of people, in order to think about the population, I don't need to necessarily observe everyone in the population. I only need to observe a sample. If it's a good sample and it's representative of the population, well, then I should be able to make kind of deductions based on that, what we call inferences. Common parameters we've spoken about. These are some parameters we've spoken about before. The population mean, which we said before was denoted with that symbol. That's mu, a Greek symbol, population mean. Population standard deviation we denoted with little sigma. And the population proportion we denote with just the letter p. Okay, lowercase p. So every population, depending on the question, you can calculate the mean of a population, you can calculate the standard deviation, you can calculate a proportion, depending on what question is being asked. Same with a statistic, same with a sample. You can calculate a sample mean, which we generally call x bar, so we give them different symbols just so we can kind of differentiate between the two. Sample standard deviation is usually given the symbol s, and sample proportion is usually called p hat. So a confidence interval is a numerical interval on which we think some parameter probably lies. So what is a confidence interval? Well, that's what it is. It's an interval. An interval is kind of a collection of numbers that have a lower limit and an upper limit. And the interval will contain every single number between that lower and upper limit, including the upper and lower limit. So you might have a confidence interval that has a lower limit of 0.4 and an upper limit of 0.6. Okay? And we think that some parameter probably lies somewhere in here between these two numbers. That's what we're saying. So confidence interval, it's a numerical interval, just an infinite collection of numbers that has a lower limit and an upper limit, on which we think some parameter probably lies. So we think something probably lies, some characteristic of the population. Maybe it's the proportion, maybe it's the mean, okay, something like that. In this class, I'm only going to be talking about confidence intervals for the proportion. Okay, so we are only going to look at in this class one type of confidence interval, and this is a 95% confidence interval for the proportion. Okay, so it's called a 95% confidence interval for the proportion. So a couple of things about that. It's a confidence interval in which we can say with 95% certainty, so that's why we call it a 95% confidence interval. We will be kind of right 95% of the time, so we'll be 95% certain that the true population proportion lies on this confidence interval that we're going to develop. Remember, from every sample we can find a confidence interval, and from every sample a 95% confidence interval can be constructed. And 95% of these confidence intervals will contain the true population proportion, and 5%, the rest of them, will not. Okay? So when we take a sample and we construct a confidence interval, we are going to kind of make a guess that it's more likely that our confidence interval will be one of the 95% of confidence intervals that do contain the population proportion p. Remember, p represents the population proportion. Okay, another thing we've mentioned before, just so I can introduce this, we're going to approximate the margin of error for the proportion to be E equals 1 over root n. Okay, so in this class we're going to be approximating the margin of error for the proportion to be E equals 1 over root n. That's our plan. So how do we construct a population, or sorry, a 95% confidence interval for the proportion? Well, let's have a look at a particular example and see how we go about doing this. So suppose a sample of 400 people underwent trials for a recent flu vaccine, and it was discovered that it was successful in 264 cases, and I'm asked to construct a 95% confidence interval for the proportion. Remember, the population is everyone who will be taking the flu vaccine, which maybe is everyone in the world, almost 8 billion people. And we've taken a sample here of 400 people. Not a very big sample, not a great sample. Really, we'd need to be a bit bigger if we're with our sample, if we're representing such a large population. However, but just for ease of explanation, we're going to look at this. So it says a sample of 400 people underwent trials for a recent flu vaccine. It was successful in 264 cases. Construct a 95% confidence interval for the proportion. So we're trying to kind of essentially guess something about the true population proportion. So we're having a guess about the true population proportion. So what do? Well, we take our sample and we find the sample proportion. So p hat is the sample proportion. And when you're going to construct a 95% confidence interval for the proportion, you're always going to start by calculating p hat. And p hat is just going to be the number of successful cases, in this case 264, divided by the total number of people in the sample, which is 400. Remember, this quantity here is known as little n. So n, that's a statistic, is 400 people. Capital N, remember, is the population size. It doesn't actually tell us what it is in this case. So p hat is 264 divided by 400. That's my population proportion. Generally, we're going to kind of decimalize that, or even turn it into percentage, because that's really what we want to be able to think about. So 264 out of 400, that is 0.66. So that's my p hat, that's my sample proportion, is 0.66. I've just plugged it into a calculator there. The next thing I'm going to do, so actually, even before I go to the next thing, if you think about this, if I'm saying that the proportion of people in my sample where this flu vaccine was successful was 66%, we might say, well, look, if 66% of trials were successful, well, then maybe 66% of the actual population would be successful. Okay? However, there's a margin of error in there, and we're going to calculate that margin of error next. That's my next plan, is to calculate the margin of error. So to calculate the margin of error, I'm just going to use my formula I mentioned there. It's 1 over the square root of n. This is an approximation, so we're going to say, maybe use my approximately equal to there. So little n, well, that's the sample size, so it's 1 over the square root of 400. And again, what we want to do is we want to decimalize that, so that's 1 over 20, which is equal to 0.05. Okay? Now, my 95% confidence interval will look like this. It's going to have a lower limit, of p hat, subtract e, and it'll have an upper limit of p hat plus e. So we work out the population proportion, we subtract the margin of error. In this case, that's 0.66, subtract 0.05. And that'll work out as 0.61. And then we look at the upper limit, which will be 0.66 plus 0.05, which in this case would be 0.71. So my 95% confidence interval for the proportion is, well, it starts at 0.61 and it finishes at 0.71. Okay, so that's my 95% confidence interval for the proportion. Another way to write that is that we think 0.61 is going to be less than the proportion, which is going to be less than 0.71. Okay, so this is how we construct a 95% confidence interval. And if I want to put this into words, you know, how do I do that? Well, I would say that I am 95% confident that the true population proportion lies between 0.61 and 0.71. Or you could put that into percentages, 61% and 71%. So that's how I would interpret that. Now, what does this mean? Well, in the context of this question, it means that I'm 95% confident. I'm 95% confident that the true proportion of successful flu jabs will be between 61% and 71%. Okay? I can't say for certain that it's going to be exactly equal to my 0.66. So we build a confidence interval around that. Notice my proportion will be exactly halfway between, my sample proportion will be exactly halfway between those two things. So what we're saying is, we think, we're 95% confident that the true population proportion lies between 0.61 and 0.71. Now, that's just one sample. Remember, I said that there's loads of samples that can be taken of 400 people. Lots and lots. Well, 95 on every single sample, we can construct a 95% confidence interval. And in 95% of those confidence intervals, we will be right, essentially. 95% of confidence intervals will contain the true population proportion. 5% of them will not, so we're not absolutely certain that ours is one of the 95%, but there's a very good chance. You know, we would be wrong probably 19 out of 20, we'd be wrong 1 out of 20 times, which is 5%. We'd be right, we would expect to be about 95% of the time. Okay? And that's how we construct a confidence interval for the proportion. In fact, that's how we construct a 95% confidence interval for the proportion. So a couple of basic steps. Calculate your sample proportion, calculate your margin of error, figure out what your lower limit is, figure out what your upper limit is. You can write it like this using interval notation. You can write it like this using an inequality, and you have to be able to interpret that. Okay? So practice some of those confidence intervals.